Technological advancements have been a turning point for lives' transformation in human history. As industrial revolution shifted human labor to machines, the boom of technological revolution began. Humanity is once again at a major turning point in history. The development of advanced technologies presents numerous challenges, such as standardization, interoperability, and regulation. To address these requires efforts from governments, businesses, academia, and research institutions. Robots, UAM, and autonomous driving technologies integrated with next-generation telecommunication promise new possibilities by breaking down boundaries based on hyperconnectivity. Advanced unmanned production environments implemented by enhanced robots. Commercialization of metropolitan transportation connecting between cities. Safer mobility through fully autonomous driving. The new era heralds by the unity of advanced technologies. Rodney Brooks, the luminary of robotic engineering. Kevin Blankespoor of Bostontdynamics, who ushered the era of the humanoid robot. Global experts forecast the future brought by AI-powered mobility. Armed with next-generation telecommunications, and they are discussing policy support to realize the vision. Strong Korea Forum 2024. The new journey to a refreshing era begins.
자, 그럼 포럼 시작하도록 하겠습니다. 스트롱 코리아 포럼 2024를 찾아주신 내빈 그리고 모든 참석자 여러분 환영합니다. 먼저 인사드리도록 하겠습니다. 저는 오늘 포럼의 진행을 맡은 아나운서 김현정입니다. 반갑습니다. 네, 감사합니다. 또 바쁘신 일정에도 또 이른 아침부터 본 포럼에 참석해 주신 모든 분들께 진심으로 감사 인사드리겠습니다. 자, 이미 많은 분들이 공감하고 계실 텐데요. 이제는 로봇, AI라는 단어가 어색하지 않을 만큼 우리 일상과 함께하고 있습니다. 그런 만큼 스트롱 코리아 포럼 2024 올해는 차세대 통신과 로보틱스 새로운 시대를 주제로 차세대 통신, 로봇, AI 모빌리티 기술 발전이 우리 일상에 어떠한 긍정적 변화를 가져줄 수 있을지 깊이 탐색해보는 시간 갖도록 하겠습니다. 또한 최근 정부는 로봇과 도심 항공 모빌리티, 자율주행 기술의 개발을 적극 지원하고 있는데요. 이 모든 기술은 인공지능을 중용으로 운영된다는 공통점이 있습니다. 네, 앞서 영상에서 함께 보셨듯이 차세대 통신은 AI가 장착된 로봇, 모빌리티 기술이 더욱 신속하고 또 안전하게 진화할 수 있게 하는 인프라로서 큰 의미를 가지고 있는 만큼 오늘 포럼에서 어떤 내용으로 이야기를 나눌지 무척 기대가 됩니다. 모쪼록 오늘 각 분야를 대표하는 국내외 전문가분들을 한자리에 모시고요. 첨단 기술 융합이 가져올 미래를 함께 전망하며 이를 실현하기 위한 정책적, 기술적 지원 방안을 모색하고자 하니 끝까지 함께해 주시기를 부탁드리겠습니다. 자, 그럼 지금부터 스트롱 코리아 포럼 2024 개회식을 시작하겠습니다. 네, 큰 박수 한번 부탁드리겠습니다. 자, 먼저 이번 포럼의 주최기관인 한국경제신문 김정호 사장님이 개회사를 해주시겠습니다. 김정호 사장님을 큰 박수와 함께 무대 위로 모시도록 하겠습니다.
여러분 안녕하십니까? 한국경제신문 사장 김정호입니다. 스트롱 코리아 포럼 2024에 참석해 주신 여러분 반갑습니다. 한국경제신문이 과학기술정보통신부와 공동으로 주최하는 스트롱 코리아 포럼이 올해로 12번째를 맞았습니다. 오랜 기간 포럼을 아껴주신 여러분께 깊은 감사의 말씀 드립니다. 특히 대한민국 기술 발전을 이끌고 계신 이종호 과학기술정보통신부 장관님, 포럼을 주관해 주신 특허 전략개발원 이재우 원장님, 그리고 후원을 맡아주신 한국과학기술단체 총연합회 이태식 회장님과 한국과학기술한림원 유욱준 원장님 대단히 감사합니다. 올해 포럼의 주제는 차세대 통신과 로보틱스, 새로운 시대입니다. 정부는 로봇 도심 항공 모빌리티와 자율주행 기술 개발을 적극 지원하고 있습니다. 핵심 기술은 모두 AI입니다. 이러한 AI 모빌리티는 앞으로 다양한 산업 분야에서 혁신적인 변화를 가져올 것입니다. 오늘 다룰 많은 미래 기술은 6G와 같은 차세대 통신 기술과 결합해야 안정적인 발전을 이룰 수 있습니다. 이 밖에도 많은 과제가 존재합니다. 표준화와 상호 운용성, 규제 문제를 해결하기 위해 정부와 기업, 학계가 모두 지혜를 모아야 할 때입니다. 이를 위해 국내외 최고 전문가분들을 모셨습니다. 기조연설을 맡아주신 로드니 브룩스 로버스트닷AI 창립자 겸 최고기술책임자님, 케빈 블랭크스푸어 보스턴다이내믹스 수석부사장님 고맙습니다. 도심 항공 모빌리티 대표기업 조비 에이비에이션의 에릭 앨리슨 부사장님과 세계 처음으로 자율주행 서빙 로봇을 출시한 베어 로보틱스의 존 하 최고 경영자님은 미래 산업의 판도를 바꿀 혁신적인 기술을 선보일 예정입니다. 글로벌 협력 강화와 신기술에 관한 활발한 논의를 기대합니다. 또한 삼성전자, LG전자, SK텔레콤, KT, LGU+, 네이버랩스, 카카오 모빌리티, 한국항공우주연구원, 레인보우 로보틱스, 마스 오토 등 국내 각 분야 대표 기업들이 차세대 통신, 로봇, UAM, 자율주행 등 첨단 기술을 소개해드릴 예정입니다. 오늘 포럼을 찾아주신 모든 분들이 각 세션에서 유익한 정보를 얻어가시길 기대합니다. 한국경제신문은 앞으로도 첨단 기술 강국 도약에 기여한다는 사명감을 가지고 포럼을 더욱 발전시켜 나가겠습니다. 다시 한번 참석해 주신 모든 분께 감사 인사드립니다. 여러분의 일터와 가정에 늘 건강과 행운이 함께하길 기원합니다. 여러분 대단히 고맙습니다.
네, 또 뜻깊은 말씀을 전해주신 김정호 사장님께 다시 한번 감사 인사드리겠습니다. 말씀 주신 것처럼 오늘 여러분께서 모쪼록 좋은 인사이트를 많이 얻어가시기를 저 또한 기대해 보겠습니다. 네, 이어지는 순서는요, 공동 주최기관인 과학기술정보통신부 이종호 장관님의 환영사입니다. 그럼 이종호 장관님을 큰 박수와 함께 무대 위로 모시도록 하겠습니다.
안녕하십니까. 과학기술정보통신부 장관 이종호입니다. 과학기술정보통신부와 한국경제신문이 공동 주최하는 스트롱 코리아 2024 포럼에 오신 것을 환영합니다. 먼저 포럼을 주관해 주신 한국연구재단 이광복 이사장님, 한국특허전략개발원 이재우 원장님께 감사드립니다. 발표와 토론을 위해 자리하신 전문가 여러분, 특히 먼 길을 오신 해외 참석자들께 따뜻한 환영의 인사를 드립니다. 아울러 2002년부터 스트롱 코리아 캠페인을 통해 국가과학기술 육성에 공감대를 넓히는 데 애써주신 김정호 사장님과 한국경제신문 관계자 여러분께 이 자리를 빌려 감사드립니다. 올해 포럼의 주제는 차세대 통신과 로보틱스로 최근 전 세계적으로 관심이 높아지고 있어 저도 오늘 논의에 많은 기대를 하게 됩니다. 오늘날 문화와 산업이 디지털에 기반하고 AI와 융합하여 새로운 가치를 창출하는 디지털 심화 시대가 전개되는 가운데 통신, 즉 네트워크는 기반 인프라로서 그 역할이 절대적으로 중요해지고 있습니다. 특히 6G가 구현되면 공중, 해상 등을 포함한 이른바 초공간 입체 통신을 통해 자율주행, 미래항공 모빌리티 등 혁신적 서비스가 가능할 것입니다. 드론, 자율주행차에 국한되었던 모빌리티는 6G에 기반한 로보틱스와의 융합으로 기능과 역할이 눈부시게 향상될 것으로 전망됩니다. 심해, 고산지대, 원양 등 험지의 모빌리티 융합 로봇이 투입되고 육해공의 다양한 로보틱스가 협업으로 시너지를 창출할 수도 있습니다. 이에 따라 정부는 올해부터 본격화될 6G 표준 일정에 맞춰 6G 기술과 표준 주도권을 확보하기 위해 전방위적인 지원 정책을 추진합니다. 먼저 기존의 원천 기술 중심 6G R&D에 더하여 상용화 기술과 글로벌 표준화까지 종합적으로 지원하는 4,400억 원 규모의 R&D 사업을 올해부터 진행합니다. 또한 6G 표준 터크를 30%까지 보유하여 국제 표준의 주도권을 확보할 수 있도록 ITU, 3GPP 등 국제기구의 표준화 활동을 적극적으로 이어갈 것입니다. 아울러 민, 관, 산, 학연 협력 체계인 6G 포럼을 통해 6G 이종 산업 융합을 위한 서비스 발굴, 글로벌 리더십 확보 등 6G 산업 생태계를 구축하고자 합니다. 로보틱스는 반도체, AI, 2차 전지, 첨단 부품 등 산업 간 융합을 촉진하는 핵심 기술로 생산 효율성 혁신의 기반으로 부각되고 있습니다. 최근 인구 감소에 따른 사회 문제 해결의 핵심 수단과 극한 환경 임무 수행 지원 등을 위해 우리나라 로보틱스 기술 확보가 중요하게 되었습니다. 따라서 정부는 글로벌 경쟁력을 확보할 수 있도록 미래 로보틱스 연구개발 활성화를 위한 핵심 인력 양성, 국제 협력, 제도 및 인프라 구축 등을 지원하겠습니다. 이와 함께 미래 로보틱스와 로보틱스 간 기술 융합과 새로운 운용 서비스 창출도 적극 추진해 나갈 계획입니다. 이런 가운데 국내외 최고 전문가들이 모여 NextG, 차세대 통신으로 파생될 혁신과 미래에 대한 논의의 장이 마련된 것은 대단히 시의적이라 생각됩니다. 오늘 포럼에서 차세대 통신과 로보틱스를 중심으로 한 새로운 변혁의 가능성과 경쟁력 강화 전략에 대해 깊이 있는 토론이 이루어지길 바랍니다. 아울러 정부는 지난주 AI 서울 정상회의에서 다시금 확인한 것처럼 안전, 혁신, 포용 등 핵심 가치를 바탕으로 대한민국이 디지털 문명을 주도할 수 있도록 계속해서 노력할 것입니다. 디지털 심화 시대의 최고 전문가인 여러분께서도 대한민국이 세계사회의 디지털 모범국가로 자리매김하는데 많은 관심과 도움 주시기를 부탁드리겠습니다. 자리해 주신 모든 분께 다시 한번 감사드리고 많은 성과와 보람 있으시길 기원드립니다. 감사합니다.
네, 이종호 장관님의 뜻깊은 말씀 다시 한번 감사드리겠습니다. 또 앞서 말씀 주셨듯이 이 협업의 시너지를 강조를 해주셨습니다. 협업을 통해서 앞으로 대한민국의 미래가 밝게 나아갈 수 있도록 저 또한 기대해 보겠습니다. 자, 이어지는 순서는요, 윤석열 대통령님이 포럼 개최를 축하하는 축사를 보내주셨습니다. 대통령님의 축사는 성태윤 대통령비서실 정책실장께서 대독을 준비해 주셨습니다. 성태윤 실장님을 큰 박수와 함께 무대 위로 모시도록 하겠습니다.
스트롱 코리아 포럼 2024 개최를 진심으로 축하합니다. 뜻깊은 자리를 마련하신 한국경제신문 김정호 사장님과 임직원 여러분, 그리고 함께하신 과학기술인과 경제인 여러분께 감사드립니다. 올해로 12회를 맞는 스트롱 코리아 포럼은 국내외 과학기술 리더들이 한자리에 모여 첨단 과학기술의 미래와 발전 방향을 모색하는 우리나라의 대표적인 과학기술 포럼으로 자리 잡았습니다. 범국민 캠페인을 이끌며 과학기술 강국 육성에 선도적 역할을 수행하고 있는 스트롱 코리아 포럼에 힘찬 박수를 보냅니다. 올해 포럼의 주제인 차세대 통신과 로보틱스는 첨단 산업을 견인하는 중추적 기술이자 강력한 미래 신성장 동력입니다. 6G, 양자 암호, 나아가 양자 통신을 아우르는 차세대 통신은 국민 모두가 누려야 하는 디지털 기술의 핵심 인프라이며 경제 안보의 핵심 기술이기도 합니다. 로보틱스 분야 역시 인공지능과 메카닉스가 융복합된 첨단 기술로 전후방 산업에 대한 파급 효과가 매우 큽니다. 우리 정부는 차세대 통신과 로보틱스를 12대 국가 전략 기술로 선정하여 지원에 힘을 쏟고 있습니다. 핵심 기술 확보를 통해 산업 경쟁력을 높이고 글로벌 시장에서 우위를 선점할 수 있도록 든든히 뒷받침할 것입니다. 오늘 이 자리가 우리 경제의 도전과 혁신을 이끄는 활발한 논의의 장이 되길 기대합니다. 여러분께서 제안해 주신 고견들을 정책에 적극적으로 반영해 나가겠습니다. 다시 한번 오늘 포럼을 축하드리며 여러분 모두의 건승과 발전을 기원합니다. 감사합니다. 2024년 5월 29일 대한민국 대통령 윤석열 대독했습니다.
네, 축사를 보내주신 윤석열 대통령님 감사합니다. 또한 대독해주신 성태용 정책실장님께도 감사의 말씀 드리겠습니다. 자, 이상으로 저희는 개회식을 모두 마무리하고요. 기조연설을 시작해 보도록 하겠습니다. 네, 기조연설 시작 전에 잠시 안내 말씀 드리겠습니다. 이번 포럼은 실시간 질의응답 시스템을 이용해 질문을 받고 있습니다. 오늘 두 분 기조연사분들도 질문을 받을 예정이니 궁금한 점이 있으시다면 명찰 상단의 QR코드를 스캔해 질문을 올려주시면 강연이 모두 마친 뒤 사회자인 제가 대신해서 질문을 전달드리도록 하겠습니다. 자, 그럼 첫 번째 기조연설 시작하겠습니다. 스스로 결정하고 실행할 수 있는 행동 기반 로봇공학 개발과 함께 로봇의 지평을 넓힌 로봇의 거장 로드니 브룩스 로버스트닷AI 창립자 겸 최고기술책임자께서 로봇이 클라우드를 만날 때 AI의 파격적 혁신을 주제로 발표를 준비해 주셨다고 합니다. 그럼 큰 박수로 환영해 주시기를 부탁드리겠습니다.
Thank you.
So, Mr. Bruce, please give us a lecture, if you're ready.
I'm ready. I'm so honored to be here today. Thank you for inviting me. We live in an interesting time in technology. It is confusing. There is a lot of hype about some aspects of AI and some aspects of robotics. And I have always felt that the role of infrastructure has been underplayed. So I'm very happy to be here at this conference where we're talking about infrastructure, because infrastructure is important for any technological transformation. And the attention has been to look at what this robot can do instead of how does the robot fit in a whole system and provide value to all of society. In determining what robotics is going to look like, or any technology is going to look like, I think we have to look at what is the long-term important things in the world, the things that drive technology. And there are two things. There are megatrends. Megatrends are things that humans are causing but did not design to cause. They didn't mean to cause them. And I'll talk about those in a second. And then there are technology trends. And these are deliberately driven by humans, by companies, by governments, with particular goals in mind. The megatrends, we all know them. There's climate change. Humans didn't set out, let's burn more carbon and make the planet hotter. It just happened, and we are stuck with where we are with climate change. There's urbanization. People want to live in cities, and so there's a large number of people moving to cities, and cities will change. And lastly, there's demographic inversion. The minister pointed this out, and how that impacts robots. This is data from the US Bureau of Census Bureau, which is for Korea, as you might notice. And clearly, Korea is the lead in lower birth rates. But even the most recent predictions from the United Nations about peak human population in 2080 seems to be undermined in the last 3 or 4 years, that birth rates are going down in Africa and other places much faster than was expected. So this is a very dynamic situation that's going to change. The megatrends, I think they're the 3 important megatrends which will, what happened there? Can we start again? No? Why are we? Okay, I'll skip through, okay. Then there's technology trends. And the technology trends come after, I think, the most astounding technology trend in the history of humankind. And that was Moore's Law. Moore's Law operated for 50 years. And if you read Gordon Moore's original paper in 1965, he only predicted out for 10 years, but it worked for 50 years. Now Moore's Law has come to an end. Classical Moore's Law has come to an end. Moore's Law was about the price of transistors getting cheaper as they got smaller. And today we see that a 3 nanometer feature size transistor costs twice a 5 nanometer size transistor. So we have come to the end. But don't worry, people are really excited about making things better, and the number of cores per chip is going through the roof. Typical number of cores on a CPU is 8 or 16, but there are thousands of GPUs, and the price of those continues to go down. AI techniques, we've had artificial intelligence for, it's actually 70 years since artificial intelligence was founded. I've worked in it for 50 years. Machine learning, 2012, deep learning. Now we have generative AI, and generative AI is sort of at the peak of its hype cycle. It will change over the next 2 or 3 years. But there are new AI techniques, a lot of them. And then next generation telecommunication. I took this picture from the logo for this conference. I didn't know how to show next generation telecommunication better than that. Now, I build robots, so I see everything in the world as robots. That's how I view the world, in terms of robots. So these megatrends, climate change. We will have climate refugees as places get hotter and hotter. I grew up in Australia. It was already very hot in the desert where the mines are. It's getting worse. People don't want to live out there, so there's a lot of automation, enormous trucks for the iron ore mining, which are supervisory controlled from about 1,600 kilometers away in Perth. That's real today. So we'll have to have robots working in places where before people worked. And because of climate change, rising waters, an incredible amount of work in all our cities to handle coastal rebuilding. I'm currently living in San Francisco, the San Francisco Bay. All around the bay, people are building retaining walls, big retaining walls, big projects to stop water getting in. When I was in Boston, my company was in the in the port district of Boston, and we were getting flooded, 1 in 100-year floods every 3 months. So we have to rebuild our cities. What do we do with that? We use robots for it. So robots are going to be important. Urbanization, need labor for building, again, robots. Demographic inversion, we are going to have difficulty across the world 100 years from now maintaining the lifestyle we have developed because there'll be less labor. So we need labor for society, and as everyone knows, in most advanced countries, we already need labor for elder care. So more robots. In terms of technology trends, it's just good news. Cores per chip going up, dollar price going down, great for robots. AI techniques, great for robots. Next generation telecommunication, great for robots. And I am so pleased to be here where we're talking about telecommunication for robots, because most people in robotics do not think about that, because they're still at the shiny, flashy stage of getting a robot to do something, but to deploy it, to really put it into our lives, we need better telecommunications to the robots. And I'll talk about ways in which we need to build upon 6G, not just 6G. There's a lot more above that. So when I view these three things, here I am in Korea talking about megatrends and technology trends. It's all about robots, ultimately, which makes me very happy. So Isaac Asimov was a science fiction writer in the United States, and he, in the 1950s, developed his 3 laws of robotics. And I've been working in robotics for 45 years, and everyone has always asked me, do your robots obey the 3 laws of robotics? And I've always had to say no. And not because I didn't want the robots to not injure a human, but because we didn't have perception capabilities good enough for the robots to know that that was a human right there. So it couldn't make decisions about it. And certainly we haven't had AI able to predict what's going to happen next in order to avoid a future injury of people. The robot must obey orders given it by a human. Mostly our robots have ignored humans and haven't obeyed any orders at all. We just haven't been able to build them in a way where humans can interact with them easily. And a robot must protect its own existence as long as such protection doesn't conflict with the first 2 laws. Well, I think that's asking a little too, it's promoting robots a little too much. It's okay if robots get hurt and break. They're just machines, and we should remember that. Now, I've worked on a lot of robots over time, first at MIT, where I was a professor for many years, and then in my companies. Some of the things I've done, the first robot that could navigate through a crowded room. Now, we see that all the time. Bear Robotics is here. They do it all the time. I see your robots out in the world navigating around people and doing a great job of it. But it was really hard back in 1985 to make that happen. And there, the idea is that the robots don't hurt people. They're aware of people. In 1985, we didn't know there were people. We just knew there was a cloud of data there. We better not hit that data. But now we can actually label the data as a person. And I worked on other robots, including walking robots that eventually became the Mars rovers, and also built some humanoid robots at MIT. I built the torso upwards of humanoid robots because Mark Rabert, the founder of Boston Dynamics, was there. He built the bottom half of the robots, but we never put them together. And then in companies, I've been building robots that are deployed in real tasks for real people, real customers. So the Roomba was the first mass market home robot. That company has sold 50 million of those now, and other companies gave us a lot of competition, including LG and Samsung, soon became very strong competitors. And so there's a lot more of those robots around. We deployed the first robots to war zones in 2002 to 2010. I'll tell you about that in a minute. And then I've developed humanoid robots in factories and delivered thousands and thousands of those around the world. And in doing that, I've come to realize certain things about robots which are a bit different from Isaac Asimov's laws. You know, Isaac Asimov got old, he had white hair, I've got white hair, so I think I'm old enough now to have my 3 laws of robotics. And here's my 3 laws of robotics. The visual appearance of a robot makes a promise about what it can do and how smart it is. It needs to deliver or slightly over-deliver. So I say to people who are building a robot that looks like Albert Einstein, if your robot is not as smart as Albert Einstein, people are going to be disappointed. If your robot has a 4 or 5-fingered hand and all it does is go like that, they're going to be disappointed. Why has it got that complex hand if it's not actually doing anything? Why can't it do this like our hands can and manipulate and turn things around? So a lot of robots that we see are dressed up with a great appearance, which makes people think they're going to do a lot, but not all of them do. When robots and people coexist in the same spaces, the robots must not take away from people's agency. That means you can't have robots that get in the way of people. And I've seen this repeatedly. One of my favorite examples is robots in hospitals doing deliveries or taking the dirty sheets down to the laundry so that the nurses don't have to do it. But what we often see is the robot is going along, and now here coming down the corridor are some nurses with a gurney with a patient on it, and they're running, and the robot doesn't know how to handle that, so it just stops in the middle of the corridor. Now it blocks the corridor from the nurses with their patient. The nurses get really, really upset. They get really annoyed with it because the dumb robot is stopping them from doing their task, which is saving someone's life. So we have to always allow people to have agency over robots, or otherwise they'll get very upset. Another example of this was the General Motors robots made by, in the company Cruise, autonomous robots in San Francisco. We've had almost 1,000 of them driving around. I've ridden in them many, many times. But they would drive into where firefighters were fighting a fire and just try to go around the fire engines and around the firefighters. No person would do that. Any person would, I'm staying away, I go away. But these robots, vehicles, were just going through and causing incredible problems for the firefighters. So the head of the fire department in San Francisco said to the firefighters, it's okay to get a sledgehammer and smash the windscreen of one of these robot cars because we can't have them messing up firefighting. So it's important to let people have control over their environment because robots will always fail at some level. And lastly, we see brand new technologies, they look fantastic, but we can't expect them to be putting real robots in real deployments immediately. It takes years for new technologies to mature. So in 2012, there was a revolution in computer vision with deep learning applied to computer vision. Started to be able to label images in ways we had not seen before. But it was not practical to take those algorithms at that point, not prudent, and put them into deployed robots because we didn't know how to characterize how well they work. 10 years later, we know how to characterize them. We know how reliable they're going to be, and we can put them in our robots and operate safely. So with the Roomba, the iRobot Roomba, it didn't look like a person who was cleaning the house. No one expected this robot to clean the tops of tables or wash the windows. It's just a little thing that rolled around on the floor. So its expectations were very low. Just pick up some dirt and put it in the bin, and that's what people expected. By the way, if you look carefully, there's actually a handle on the robot, so you can grab it and pick it up, so that if it's causing trouble, if it's in cords or doing something bad, you can just grab it and move it. So the people in the house, have agency over the robot. In Iraq, we deployed 6,500 robots to deal with roadside bombs. Instead of a soldier having to put on a bomb suit and go out and poke the bomb with a stick, now the robot got sent out, but it was teleoped. And at first we had a complex interface, and it was difficult for the 19-year-old soldiers to control the robots, so we put Game Boy controllers on it. Oh, I don't know why that is happening again. Can we go back to where I was? Do I have to do something? If you could try and fix those slides. Thank you. So we put a Game Boy controller, and now all the soldiers knew how to operate the robot. They didn't know how to make 100% use of it, but they could use 80% of it, and it was useful. So again, making things easy for people to use. We had those robots in Fukushima Daiichi 1 week after the great tsunami, and it was a 40-year-old. It was a 40-year-old nuclear power plant, had no digital communications, so the robots provided mobile infrastructure, which better telecommunications would have done. One forward. The robots went out and became Wi-Fi hotspots and set up telecommunications on the fly, and that's how the Tokyo Electric Power Company officials were able to know what was going on in many of those reactors because they could get images of the analog dials. A great example of telecommunication missing from a system. And then with my robots, Baxter and Sawyer, at Rethink, there's a person standing with his back to the robot. We made them safe so that it was safe for people to be around the robots. If they were going to move and hit them, they detected the hitting and stopped. And then people could teach the robots by grabbing the arms and showing them what to do. At my current company, we're building robots for warehouses, and we have the robots in different modes. Autonomous mode, sometimes the robots are just going off somewhere, taking stuff in the left. In the middle is robot-guided mode, where the robot tells the person where they should be going, and they hang on to the robot and follow the instructions. Or in the right-hand side, the person takes over and guides the robot. The robot tells them which box to put things in, makes them about 50% more efficient than they would be otherwise. But robots in different modes. It's not just about the robot. It's about how the robot fits into a larger system and fits in with people. So we put handlebars on our robots. They look like shopping carts. We don't have to train people. If someone sees a handlebar, they know they can grab it, then they can control the robot. So these are some of the robots in a DHL facility in Columbus, Ohio. And there's mixed control. There, someone puts something on the robot and says, go off and take this somewhere, and off it goes autonomously. Or here, the robot is wandering along, the person sees the robot and decides they want to take control, so they just grab the handlebar, and now they have complete control over the robot. This is very different from it being robot-centric. It starts to become people-centric. And for people-centric, we're also going to need more communication. Here's the robot in person-guided mode, where the person's pushing it down, but now the handlebars lock into understanding the geometry of the aisle and only let the robot move in an X and Y direction and not other directions. So it makes it easier for the person to control it. And we make the robots deferential to people. So a box is very different from a person, and the robot avoids the person more than it avoids the box. And again, Bear Robotics, I see them I see them deployed. It's that's just about the most deployed mobile robot I see outside of homes, where it's safe, they're in crowded environments in airports, and they don't hit the people. That's a great thing to be having. And lastly, here's two carts. One is the smart robot cart coming from above. One is just a conventional cart coming from the left. Both are being pushed by a human. But the robot that's being pushed sees what's happening and stops and doesn't let the person push. So it provides safety, which is getting back to Asimov's laws about not causing damage and not letting the person take inappropriate actions. Now, to do this, and I think this is going to be true for all future robotic systems, we need AI on the robot being able to make decisions rapidly and being able to do things without communications. We need fleet intelligence over on the right there, where there is something in the cloud controlling the robots. But more than that, it's sharing information. So here the robot on the left is coming along, and there's a pallet on the ground. The pallet on the ground is blocking that corridor somewhat. That information should go to the cloud. But it's a semantic thing. If it was a person blocking the aisle, it would be very different from a pallet blocking the aisle. The robot has to have enough AI intelligence to know that a pallet will not move by itself. A person is likely to move by themselves. It's not a permanent thing. It doesn't need an intervention to change stuff. So, under the topic of this conference, the theme of this conference, let me go back. Sorry. Under the topic of this conference, I want to talk about how telecommunication can make something work which didn't work before. And I'm going to use as my example autonomous vehicles. Autonomous vehicles, people got excited around 2007 with something called the DARPA Urban Challenge, where we had multiple robots from multiple universities and companies driving around a small town and interacting with each other and not causing collisions. And people got very excited. Okay, we're going to be able to deploy this out into the world. And the hype was tremendous. So by and the idea, the conceit was that there'd be a one-for-one replacement for human drivers, and we wouldn't have to put any infrastructure in. So it's going to be cheap. Private enterprise would just build better cars, and then you wouldn't need human drivers. That didn't turn out to be the case. This is a screen capture I took in 2017, which I've annotated, with company after company saying when, in blue, many of those blue dates are covered in pink, the ones that are passed, they were going to have level 4 driving systems. NVIDIA was going to have level 4 enabling systems by 2018. If you go to the fourth line, the CEO of Ford said they were going to have fully autonomous mobility services by 2021. The dates in parentheses are the years that they made these predictions. And they were all predicting stuff was going to happen very quickly, incredibly quickly. And every one of those dates that's passed, it didn't happen. The orange arrows are where I later noticed someone changed the dates they predicted, or in the case of Mercedes-Benz, say they weren't going to do it anymore. So people over-predicted, over-hyped what was going to happen. And as a result, we got lots of problems with lots of companies, and most of them are not driving autonomously in the US anymore. GM's Cruise is well over 1,000 vehicles sitting off the road not being driven. But the problem was that everyone thought that one-for-one replacement, self-driving cars would just drive along with human-driven cars, and there would be nothing else we had to do. And it became a big prize, a monoculture of learning-based methods, killed the idea of any government-led or funded digitalization of roads, and slowed down safety innovations. So I'm so pleased to see here that we're talking about how to use telecommunications to make things safer. This is from earlier this month in the IEEE Spectrum. People are starting to realize, yes, we do need telecommunications, and we need to have the robots or the autonomous cars talk to central systems and stuff come back to them. So for vertically integrated robot to cloud stacks, we need communications with low latency, with high bandwidth, but we also need robot tolerance to communication gaps. Some people think about, oh, if we've got great telecommunications, we'll do everything in the cloud. That's not going to work. We need smarts on the robots. Robots must have autonomy for some time horizon. Maybe it's 2 seconds, maybe it's 3 minutes, but they have to be able to operate safely without communications. And here's the big thing that I think people haven't been talking about. Rather than raw sensor data, what needs to be transmitted is semantic data. What does the data mean? So 6G will be talking about the communications layer, various layers on top of that, but I think there's going to be an incredible market for those who can develop traditional AI sort of data representations which are used to send semantic information rather than simple labels, and how the semantic information about what a robot observes in the world can be integrated into the cloud to a better understanding of the world. So for autonomous cars, we already have traffic data being sent for route planning. We're going to have a lot more of that. We'll need to know everything about nearby cars, nearby pedestrians. The phone will become central to that, weather services, fire departments being able to say, we're fighting a fire, don't come near here, etc. That's a semantic label of why you shouldn't come here. So, fixed sensors going to the cloud, robots communicating back and forth to the cloud. And I want to finish by saying that having built robots, deployed robots for many decades, think that better telecommunications, semantic telecommunications, for the next 10 years is going to be more important than generative AI and more important than some of the fancy forms of robots. For practical systems in the next 10 years, the biggest thing we can do is have better telecommunications at the semantic level. So I hope you'll not just build 6G, but think about semantics, think about interoperative standards, think about opening that system so that much can come in together and it can go across vendors, across different projects in different cities, different industries, and together combine to a much better understanding of the world, which will make the robots be able to do their jobs better and better. And that, for the next 10 years at least, is more important than many of the very hyped things that we see in the press. So thank you. And I think I will take some questions now, and I'm not sure how the questions are arranged. If someone can tell me, that would be great. So there's someone to tell me.
네, 로드니 브룩스 CTO님의 연설 잘 들었습니다. I would like to appreciate your speech. So please wait a moment for the Q&A session. 자, 지금부터는 여러분들이 올려주신 질문을 제가 대신해서 전달하도록 하겠습니다. Mr. Brooks, I will read the question on the screen and then interpreter will translate on the device. So please listen to the question on the device and then respond freely. Thank you. 자, 첫 번째 질문 읽도록 하겠습니다. 로봇이 클라우드로 관리되기 시작하면 지금보다 네트워크 보안 이슈가 훨씬 부각될 텐데 국제적으로 관련 규제 강화가 산업에서의 적용에 어느 정도의 영향을 미칠까요? 이에 대한 답변 부탁드리겠습니다.
Yes, of course network security is going to be important, and I'm sorry for glossing over that. As I said, I know about robots. I'm not really a security person, but that is an important aspect of that delivered package of how that security works. And of course, absolutely, there will be bad people hacking into it as soon as possible, as we know continues to happen. So yes, that is a very important thing for us to work on.
So
standards for that, standards.
So thank you for your answer. 자, 두 번째 질문 주시기 바랍니다. 최근 영화 아틀라스에서 주인공의 생명을 지키기 위해 AI가 인간의 주도권을 강제하는 장면이 나오는데 결론적으로는 AI가 인간을 구하게 되지만 그 과정에서 AI가 인간의 주도권을 강제할 수도 있다는 역설에 대한 우려는 없는지요? 라고 질문이 왔습니다. 이에 대한 답변 부탁드리겠습니다.
Okay, I think we have to be careful, and I have another talk I give on the 7 deadly sins of predicting the future of AI, and one of those deadly sins is thinking too much about Hollywood movies, because a Hollywood movie takes an idea, puts it in the existing world, and nothing else changes. In reality, any technology comes with a lot of changing. If anyone has seen Blade Runner, the robots were indistinguishable from humans, but they still used coins in payphones to communicate. So the world changes together. At the moment, nothing in AI that we have, nothing has any real agency. The systems in generative AI just flow through networks. There is no intent. There is no desire to do things. But it's been a trope of science fiction movies, including 2001. 2001 was very influential on me as a child, but the robot was a murdering psychopath, Hal, in that case. But I don't think we are close enough to have to worry about that for, I say, 300 years. It's going to take us a long time to get AI like that. It cannot do that at the moment. What it can do is provide, accidentally, security holes through which bad people will get into those security holes and then cause damage to people. Human intent exploiting weaknesses in the technology, not the technology itself exploiting weaknesses in humans.
So thank you for your answer and speech. With that, we will conclude the Q&A session. 네, 이것으로 기조 연설과 질의응답 모두 마치도록 하겠습니다. 수고해주신 로드니 브룩스 CTO님께 다시 한번 드리겠습니다. 두 번째 기조 연설 시작하도록 하겠습니다. 네, 이번에도 질의응답을 진행할 예정이니 마찬가지로 질문이 있으신 분들께서는 질의응답 시스템을 통해 질문을 올려주시면 사회자인 제가 대신해서 질문을 전달해 드리도록 하겠습니다. 네, 두 번째 기조연설은 로봇의 균형 감각과 보행 능력을 제어하는 소프트웨어를 최초 개발하고 창고 자동화 시대를 연 케빈 블랭크스푸어 보스턴다이내믹스 수석부사장께서 새 시대의 휴머노이드 아틀라스 2.0을 주제로 발표를 준비해 주셨다고 합니다. 큰 박수로 모셔보도록 하겠습니다. 힘찬 박수 부탁드리겠습니다.
안녕하세요. I'm Kevin Blankespoor with Boston Dynamics, and I'm going to talk to you about the future of mobile robotics. So I always like to start with a little bit of history of some of the robots we've built at Boston Dynamics. This is Big Dog. So this is really the first dynamically balancing legged robot that could leave the laboratory and go out and deal with real-world terrain. So this is a video of it actually slipping on the ice, and you can see this is really where we got our start with dynamic balancing algorithms that enable the robot to use its state estimation and place its feet so it can maintain its balance even though it's actively slipping and struggling. This is the follow-on robot, so this is LS3. You can see here we've added a sensor head, so we now have stereo vision, LiDAR, and all of the vision and autonomy that brings with it. This is the Cheetah robot, which had a simple goal, which was to make the fastest running robot in the world, which we did. And all of that knowledge is really wrapped up into Spot here. Spot is our first productized quadruped that we sell now. And of course, it's been redesigned for manufacturability, reliability, and cost reduction. Of course, it's not just legs. We also make some wheeled robots, but usually they have a trick up their sleeve. Sandflea here is able to leap up on buildings. And of course, we have a long history with humanoid robots. So this actually shows the Atlas robot. We're getting our start here actually moving boxes with Atlas, and I'll talk a little bit about what that led to with future robots. But here it's doing early research on contact detection, grasping, force control. We use Atlas a lot to push the boundaries. So here we are doing gymnastic behaviors. That helps us to push not just the control systems, but also it pushes actuation, battery, power, all of the things in the hardware. And of course, we've got some offshoots from Atlas. We actually took a lot of Atlas's knowledge and built Handle here. So Handle, it was our first chance to combine wheels and legs. And it's really also what led to our foray into warehouse robotics. So here's Handle. It's really kind of a product hypothesis here where we're doing pallet building and learning all about what it takes to survive for warehouse tasks. And of course, the follow-on to that was Stretch. So Stretch is here doing truck unloading. Stretch is our second product that's on sale today in America and in Europe. And it's capable of doing a wide variety of tasks in the warehouse, mostly around case handling, but this is the first one, so this is doing container unloading. So that's kind of our history, but nowadays we're a commercial business, and we're really aimed at solving this problem that Rodney alluded to earlier today. You know, one of the major issues we're going to have globally is a labor shortage between aging trends, increasing labor costs, some jobs that people just don't want to do anymore. We now have a labor shortage that's going to only grow over time. It's projected that by 2030, that will reduce in about an $8.5 trillion reduction in economic output. Now, of course, this is not really felt fully distributed. It's more acute in specific industries. So on the right, you can see in manufacturing, logistics, and automotive, there's going to be quite a few labor shortages in the coming years. And our goal is to really use mobile robotics to fill some of that gap. So I talked a little bit about some of the history. For the rest of this presentation, I'll talk about the robots that we're developing today. Two of these, Spot and Stretch, are on sale now. And of course, Atlas is a humanoid robot that we're just starting to commercialize. So let's start with Spot. Spot is our quadruped robot, and it's really sold as a mobility platform. So it's a general purpose robot. Its real talent is that it's fully mobile and can go most of the places that you and I can go. And by attaching different payloads or different application software, you can actually use it to tackle a wide variety of tasks. So here in the middle and on the right, you can see some of the tasks that we're going after now. Industrial inspection is one of the biggest. I'll talk about that in just a moment. But we also sell Spot into construction applications, public safety, nuclear and other dangerous environments, manufacturing, and entertainment. Now, the application where we currently have really the most traction is industrial inspection. So this video shows off how that works. Here, Spot's equipped with a payload on its back that's got a wide variety of sensors that do asset inspection on an industrial site. So that payload has 360-degree cameras, it has pan-tilt zoom cameras, it has thermal cameras, and it has acoustic sensors, and it's able to autonomously move an industrial site and basically inspect a lot of the assets on that site. And so it uses the cameras to actually do predictive maintenance. Here it's got a thermal image of an electric motor, and it's able to predict sometimes that a motor is going to go bad before it goes bad. That can be really valuable. You know, if you lose some of these assets in the middle of operation, it's very costly. But if you can predict they're going to go bad and then upgrade them at planned downtimes, you can save quite a bit of money. Spot's also fully autonomous, so it's able to do these missions without help from people, and it's got a great connected cloud interface to basically communicate all it learned on its missions. So these are the three types of inspections, or four types of inspections that we do now. Visual, you see things like gauge reading. There's things like thermal cameras that we use to look for hot spots, and especially when you're basically visiting the same spots daily, you can find trends where equipment's starting to fail. Same thing with acoustics. We use that for also in leak detection in pneumatics and things like that. On the right here is digital twin creation. That's actually when Spot can move through a building with an industrial or a survey grade LiDAR and create a full three-dimensional twin of a site. So on a construction site, if you can actually scan it daily, you can track its progress, compare it to the design, and catch problems early. Okay, so those are the four types of inspections, but nothing can replace an actual demo from Spot. So let's bring Spot on stage, and I'll actually show off how it works a little bit. So please welcome Spot. Of course, one of the big advantages of a legged robot is that it can handle stairs and uneven terrain. So Spot also has a vision system that enables it to see that terrain. One of the things that you can do also with a legged robot is move in any axis. So here you can see you can rotate in place. We can move side to side. So unlike a car, for example, we can move laterally, side to side. And of course, forward and backwards. We can also control robots' posture. So if you look at the body here, we can control things like the pitch, roll, and yaw of the body. So here we can control the height, for example. This is the pitch of the body. That enables Spot to see different things or help position the arm. Same thing with yaw. You can control the yaw. Again, this really gives you a much longer kinematic chain. So with controlling the body, you can point sensors, or you can really expand the workspace for the arm. I want to mention briefly the balance algorithms for Spot. So Spot, for example, right now Spot is standing still, and you might think that it's kind of locked into place, but it's actually actively balancing right now. So that means that it's monitoring its position and its orientation, and all four legs are actively trying to balance the robot. So if I just push on it a little, you can see it's kind of pushed back just a little bit. And if you push far enough so that its center of mass slips outside of its support polygon, it'll step as needed. So let's show off the arm as the kind of last step here. This Spot comes equipped with an arm, and you can see that we use the body and the arm together to get you a really complete range of motion. So the arm here is being controlled with a joystick, but really, it's capable of being controlled somewhat autonomously as well for a specific set of applications like opening doors. And again, you can see, even though the arm is not super long, we can use the arm in concert with the body, and that really enables it to do a much bigger range of motion. Now if we put the gripper in world frame, so you can see a little bit more here how we coordinate the body with the gripper. So here we're going to actually tell the gripper to kind of stay in one position. And even though the body's going to now walk around a little bit, you can see that we're able to control the gripper independently of the base of the robot. We call this station keeping. There you go. This is an important skill for doing mobile manipulation, being able to independently control the end effector of the robot from the body of the robot. That's good. Okay, thank you, everybody. Thank you, Spot. Okay, so the next robot I want to tell you about is Stretch. Stretch is our second product that we have entered into the market, and Stretch is really custom built for warehouses. So we've taken a lot of the knowledge that we've gained on our legged robots and actually repackaged them into a robot that's purpose built for the warehouse. It has an advanced vision and autonomy system. It's very flexible, and it can be deployed in just days. So let's start here. This is actually a visualization for kind of our long-term vision for the warehouse of the future. So as we zoom in here, you can see it looks like a typical distribution center, but as we take a closer look, you actually see that mobile robots are doing a lot of the material handling tasks that people typically do now. So this is starting at the inbound side of the warehouse. Stretch here is doing its first task, which is unloading shipping containers and boxes. Stretch is also capable of doing pallet building. So here's another Stretch building up pallets that are going to go into inventory. It's worth noting here that it's not just about Stretch. There's other types of robots in the warehouse of the future. So this is an autonomous mobile robot, things like this that are available now as well, that's moving through the warehouse. You can also see the early days of autonomous forklifts. So here's a high-reach autonomous forklift doing a pallet put away. Now, the most labor-intensive task you typically see in distribution centers is this one that we call case pick. And that's where a person nowadays will move through the warehouse and grab boxes from different inventory locations and build a mixed SKU pallet. Stretch is capable of doing this as well. So here's Stretch actually tugging its own pallet and building up a mixed SKU pallet. And as we move to the outbound side of the warehouse, you can see Stretch doing truck loading. This, in the future, will use a lot of the same technologies we've developed for truck unloading. And I like to point out, even though this is a visualization and this level of coordination isn't really there yet, there are existence proofs for everything I just showed you. There are versions of the robots that do all of the things I just showed you from Stretch to AMRs to forklifts. and they'll be getting much better and much more coordinated in the future. So here's Stretch in real life. So here's a video of Stretch. You can see it has a mobile base. It has 4 independently controlled wheels at the base, and it's about the footprint of a pallet. This is our first application for Stretch. So here Stretch is unloading boxes from shipping containers. We have an advanced gripper that can grasp boxes from lots of different surfaces. There's a vision system, so that mast next to the arm actually has both 2D and 3D sensors. Stretch is an autonomous robot, meaning you don't need to connect it to power or airlines. It works independently. It's got a smart pneumatic gripper here, so you can see it can pick up multiple boxes at once. That really increases its throughput, and that's what gives it the cases per hour it needs for its return on investment for the customers. And here you can see the smart gripper picking up, large, heavy boxes that enable it not just to pick up multiple boxes at once, but also boxes that have problems that are not pristine and might have some minor damage. All of this is autonomous, so nobody's operating the robot. Stretch is able to use its vision and autonomy to do this independently. You pretty much hit go, and the robot does its job until the truck is empty. Okay, so looking more closely at Stretch's form here, this is a visualization. It has a smart gripper, as I mentioned, so that's a pneumatic gripper, but it has independent sensing and control of all the different suction cups. The footprint is about the size of a pallet, which is because in a warehouse is designed for pallets. That means wherever a pallet can fit, Stretch can fit. It's got a perception mast here. It's got both 2D cameras as well as depth sensors that enables it to do machine learning algorithms for box detection, as well as sensing the environment. It's got LiDAR and a redundant safety system. The arm is custom designed for warehouse applications, so that reach gives you, access to the corners of shipping containers or enables it to reach across pallets. And the smart gripper is fairly complex and sophisticated in itself, and enables it to pick up 50-pound boxes, and not just pristine boxes, but also the real, semi-roughed up boxes that you see in the warehouse environment. You can order it with 1 or 2 batteries. A dual battery gives you 2 full shifts. And this is actually the second application for Stretch that's currently under development. So as I mentioned, case pick is probably the most labor-intensive task where multi-SKU pallets are built up. Here Stretch is doing that. So we're able to use Stretch's vision system and trajectory planning to basically build up pallets, even in pretty tight environments like this one. So here you can see as Stretch reaches its arm under the pallet rack, it's able to use its vision and trajectory generation to do that collision-free. It's also pushing boxes together tightly, so it's using contact detection and force control to build up nice tight pallets, similar to the way a person would build them. And it's able to autonomously move through these facilities and get to all the different pallet racks. Okay, so those are the 2 robots that we're currently bringing to market. But lastly, I'm going to talk about Atlas. The humanoid robot space is a really exciting space right now. A lot of different companies are starting to build humanoid robots. We've been doing it probably longer than anyone, so I'll talk a little bit about what we've done so far in the humanoid space and where we think it's going into the future. So here's a video that's just kind of showing Atlas's capabilities in terms of mobile manipulation. And by mobile manipulation, you'll see here, it's able to basically use its manipulation skills to aid its mobility. So it's found that it's got a gap. It needs to deliver the toolbox up to its friend there. So it's going to use its manipulation to basically build a little bit of a rampway so it can make it. Then it's going to come over and pick up a toolbox here. These are pretty big, heavy tools. So one of the things that Atlas is good at is it's strong. It's got 2 strong arms, and it's able to pick up heavy things. So now it's got a path. It's able to dynamically move through the environment and deliver a pretty heavy payload here. And then it's able to keep working on making its path so it can get back down, and it's going to show off a little bit on the way. Okay, so that's Atlas showing off. I want to show you a little bit about how Atlas sees the world next. So this is a look at Atlas's vision system. So this is a different behavior. It's where it's primarily doing mobility. And you can see Atlas's view of the world. So this main video shows Atlas's stereo vision. It's got depth sensing and regular cameras, and it's basically able to detect all these surfaces, as you can see here. It's also doing footstep planning, so you can see those green footsteps. It's planning into the future. That's based not just on the terrain itself, but also on Atlas's dynamic locomotion. If it needs to, it can also use its arms for mobility. So here it's got kind of a balance beam in front of it. It needs to get over, so it can pivot over that. And we've actually got, if you look at the image in the upper left here, you can see we've got two atlases working together. We're able to do this kind of coordination with the software API. And of course, more showing off. Atlas loves to backflip. Okay, so why develop a humanoid robot? It's hard. The reality is it's complicated. It has over 30 degrees of freedom, or 30 joints. It's not a simple robot to work on, but we do it for a few different reasons. One is we've really used it as a technology progression to get from the early days of Atlas onto the most modern, and that really helps us push the boundaries of hardware and software. So you can see really a steady progression in the actuation, in the power plant, in the vision system, the compute system, and all the software that gives autonomy and controls to that hardware as we progress to the right. Another reason we actually use a humanoid robot is because it's a really great platform to try out new applications. I showed Atlas moving boxes earlier, and even though we went to market with stretch moving boxes, we got our start with Atlas because, as a humanoid form factor, it's capable of doing such a wide variety of tasks. It's a great starting point. Now, sometimes we might learn that as we do some development with Atlas, pushing boxes, for example, that we could build a more streamlined, simple robot to actually, solve that problem. And so that's why we have offshoots sometimes. So here you see Atlas actually led to Handle. Handle was our kind of first deviation from the humanoid form factor as we started thinking more seriously about warehouse robotics. And then from there, Handle led to Stretch. And that's eventually how we got from Atlas to a very purpose-built robot like Stretch. And even though Atlas and Stretch look very different, the reality is that underneath the hood, if you look at the technological building blocks, they're shared and developed together. So if you look at actuation, vision systems, batteries, software, they're largely shared across these robots. One of the things that we're really pushing on now with Atlas is by manipulation. And what I mean by manipulation is it means taking advantage of Atlas's two strong arms. We think that's one of the strengths for this robot, is that it's able to actually pick up pretty large, complicated objects. So here you can see a stool. Well, there's a lot of different ways you can grasp a stool. There's a lot of different grasp points. You may want to re-grasp it in the air. You may want to place it down in different orientations. This is a research effort to really think about all the ways that you can grasp and re-grasp and place objects. And it's a lot more complicated than what you see in a lot of existing robots where it's just basic pick and place. Here we want to manipulate and place in specific ways. So that research led to this. So this is something we've been doing in concert with Hyundai. Hyundai is not just our majority owner, but they're also a huge enabler for us to understand manufacturing. That's both for manufacturing robots, but also for knowing about how to use robots in other manufacturing environments. So this is a mock-up of a sequencing station that you'll see in a lot of automotive facilities where parts are coming in and need to be sequenced for delivery to the assembly line. And it's a chance for us to practice with Atlas. So here it's picking up, again, some somewhat large and complex objects. It's just moved a wheel. Before that, it moved a sequencing strut. So, this is a real differentiator for Atlas. It's got strong grippers and strong arms. And so some of the robots you see coming out can only pick up relatively small, simple, light things. But Atlas, we really focus on picking up the things that you encounter in the real world and putting that together with mobility. So here you can see Atlas is able to move through the environment pretty quickly and shuffle around some pretty complex objects. Okay, so everything I just showed you so far was our hydraulically actuated Atlas. That's what we've really been developing for the last 15 years. But recently, there's been a big change with our humanoid robot. And that's us taking a step to commercializing it into a product. So, first of all, why do this with a humanoid? Well, one of the real key pieces of logic for a humanoid as potentially becoming commercialized is that, we live in a world built for humans. So, you know, if you have a humanoid robot that basically has the same size and reach and strength capabilities as a person, you know, it fits into most of the environments that we live and work in and can do a lot of the tasks that we can do. So if you want a general purpose robot that can do lots of different things, the humanoid's a pretty good form factor. Now, of course, the hard part is that you need the intelligence and software to really handle a wide variety of different tasks. And that's kind of the second thrust that you can't quite appreciate just by looking at the hardware here. So you have to have the ability to quickly learn a new set of tasks and diverse tasks. And for that, you know, we'll be leveraging a lot of AI. So the next step for us, you know, we're taking all we have learned over the last 15 years on our hydraulic Atlas platform and basically porting it into a fully electric Atlas robot that's designed for real-world applications, and it has superhuman performance. And by superhuman, I mean some of the ranges of motion or strength-to-weight ratio enabled to do some things that are even beyond what we can do. We think this all-new Atlas, all-new electric Atlas is going to be a great fit for factories and warehouses in the future. So here's just the first sneak peek at the new Atlas robot, and this just gives you a taste for some of the things it's capable of. You can see here, again, it's got very high range of motion or even infinite range of motion in some of the joints. That enables it to move and do some things that people can't do. So this is just the beginning of what we think Atlas is capable of. But we're excited to see that, you know, this is, by the way, the very first one built. And it's the beginning of kind of a new thrust for us at Boston Dynamics. Okay, so this is my last slide. This is kind of a visualization showing how we see all of this coming together in the future. So this is the factory of the future. And you can see Atlas and Spot and Stretch doing various jobs. This, again, is just a visualization. This isn't a real video. But here you can see while Stretch is moving and putting away boxes, Atlas is doing a lot of the heavy lifting as well. Here again, Atlas is doing a part sequencing task. So you see this on the inbound side of automotive factories. And again, we've been working with Hyundai to better understand some of these applications. And so Spot's lending a hand doing some quality control and visual inspections here. But you know, Atlas is able to use that big range of motion, strength to weight ratio, and basically move fast in automotive factories and you know, move some pretty heavy things. Okay. I think that's it. 감사합니다. Thank you.
네, 감사합니다. 지금까지 케빈 블랭크스푸어 부사장님의 연설이었습니다. 특히 사조 보행 로봇 스팟과 함께해서 더욱더 인상적인 발표였는데요. Thank you for your wonderful speech. So please wait for a moment for the Q&A session. Thank you. 네, 지금부터는 여러분들이 올려주신 질문을 마찬가지로 제가 대신해서 또 전달하도록 하겠습니다. I will read the question on the screen, so the interpreter will translate on the device. So please listen to the question through that device. So respond freely. Thank you. Yeah. 자, 첫 번째 질문 부탁드리겠습니다. 네, 스팟을 보면서 혹시 스팟을 보행 장애가 있는 사람들을 위한 탈 것으로 개발할 계획은 없을까요? 마치 말처럼 만든다면 바퀴로 갈 수 없는 곳에서도 쉽게 이동할 수 있을 것 같습니다. 라고 질문 주셨습니다. 답변 부탁드리겠습니다.
The short answer is no. We're not currently developing a version of Spot that is used to aid with disability. There is a little bit of research being done at Hyundai for exoskeletons to help with disability rehabilitation. So the Hyundai Robotics Laboratory has an effort right now to build exoskeletons to help people. But it would be a pretty big effort to do it with a quadruped. One of the big challenges there is safety. You know, you need to be very sure that you're not going to fall over and hurt somebody. So no development for that on Spot right now.
So thank you for your answer. 네, 두 번째 질문 부탁드리겠습니다. 네, 휴머노이드 로봇의 소비자용 상용화 시점과 또 보스턴 다이내믹스가 생각하는 적정 가격은 어떻게 되나요?
So the question is about the price tag for humanoid robots. Right now, what we have heard is really important for our customers is to have a payback period of about 2 years for our robots. So for both Spot and Stretch, the upfront cost needs to be, you know, at the point where you can get a 2-year payback. We think the same is possible for a humanoid robot. We don't have plans for an exact price yet, so I can't tell you that. But we do think for it to really work, it needs to be cost effective and get a 2-year payback period that's typical for industrial robotics applications.
So that's it. So thank you for all the answer. So with that, we are going to conclude all the Q&A session. Thank you. 자, 이것으로 기조 연설과 질의응답 모두 마무리하도록 하겠습니다.